The Mariana Event forced millions of fish to abandon the deep ocean, and the reason they left, the actual reason, should be making way more headlines than it is right now. Is the ocean dying? That's the question sitting at the center of all of this, and I want you to hold on to it because by the time we get to the end of this, your answer might surprise you. Something happened down there. Something that the ocean, which has been doing its own quiet thing for billions of years, had never done before in any recorded history. And the fact that most people have scrolled past this topic without a second thought is genuinely one of the strangest things about this entire story. So before we go anywhere, drop a comment right now and tell me, did you even hear about this? Because I want to know how many people walking around right now have any idea this event occurred. Okay, so let's actually set the scene here because you need to understand what we're dealing with at the bottom of the Pacific Ocean before any of this makes sense. The Mariana Trench isn't just deep. It's almost offensively deep. Nearly 7 miles from the surface straight down to the floor. The pressure at those depths is over 1,000 times what you feel standing outside right now. Temperatures hover just above freezing point. Light doesn't reach there. Nothing from the surface world penetrates those depths in any meaningful way. And yet life was there. Dense, complex, ancient life that had been quietly going about its business in total darkness for millions upon millions of years. Anglerfish with their nightmare faces and glowing lures. Oarfish stretching longer than a bus. Creatures with transparent bodies and bioluminescent patterns that look like something a child would design if they had no concept of how biology actually works. All of them perfectly shaped by evolution to handle the crushing pressure, the cold, the dark, the complete absence of everything the surface world runs on. And then they started leaving. That's where this gets strange, and honestly that's the part that didn't sit right with me when I first started going through the research on this. These aren't animals that drift. These aren't creatures that seasonally migrate or follow currents the way surface fish do. Deep sea species are anchored to their environment in a way that goes beyond habit. Their bodies are physically built around those conditions. Anglerfish brought up from depth decompress catastrophically because the pressure difference between the deep and the surface is so extreme. So when marine biologists and fishing crews started noticing these animals in places they had no business being, the immediate reaction wasn't curiosity. It was alarm. Oarfish washing up on beaches in unusual numbers along the Pacific coast. Deep-sea hagfish appearing in shallow coastal waters. Species that nobody had ever caught in surface-level nets suddenly filling those nets in quantities that didn't make sense. Fishermen off the coast of Japan, the Philippines, parts of California, all describing the same thing, hauls filled with animals they'd never seen in 30, 40 years of working those waters. And not one or two. Not a handful. Millions of individual fish across dozens of species all making the same upward journey at overlapping times. If this is hitting differently than you expected, go ahead and hit the like button because we haven't even gotten to the part that actually explains why this happened yet, and that part is the one that genuinely changes how you think about the ocean. The answer comes down to oxygen. Specifically, the disappearing of it. The ocean has been steadily losing dissolved oxygen for decades, and the rate of that loss accelerated in ways that genuinely caught researchers off guard. Since roughly the mid-20th century, global ocean oxygen content has dropped by about 2%. Now I know 2% doesn't sound catastrophic when you say it that way, but understanding the actual scale of what that means is the difference between treating this as a footnote and understanding it as one of the most significant environmental shifts currently underway anywhere on Earth. 2% of the total dissolved oxygen in every ocean on this planet is a volume that defies easy comprehension. And in the deep ocean specifically, where animals are already surviving on the absolute minimum that life can run on, even fractional changes in oxygen availability cross the line between difficult and impossible. What researchers identified in and around the Mariana region was the expansion of what oceanographers call oxygen minimum zones. These are layers within the ocean where dissolved oxygen has dropped below the threshold that complex animals can survive in. They're not new. They've always existed in certain parts of the ocean. But they're growing. Expanding vertically. Pressing downward into waters that used to be oxygenated enough to sustain the deep communities that called them home, and simultaneously expanding upward, squeezing the livable column of water from both directions at once. Animals that had spent their entire evolutionary history in the deep found their habitat chemically closing in on them. Going up, into warmer and shallower waters their bodies weren't designed for, was the only available direction that wasn't immediate death. Nobody really talks about this part. The migration wasn't a choice. It was an eviction. And the mechanism driving the oxygen loss connects directly to what's happening at the surface thousands of miles from the Mariana Trench. Warmer water holds less dissolved oxygen, that's chemistry, it doesn't negotiate. As ocean surface temperatures have climbed, the water quite literally releases oxygen back into the atmosphere rather than retaining it. But there's a second layer to this that's actually worse. The process that delivers oxygen to the deep ocean in the first place relies on cold, dense surface water sinking and mixing with deeper layers, dragging fresh oxygen down with it as it goes. That circulation process, which oceanographers call thermohaline circulation, has been measurably weakening. The conveyor belt that the deep ocean depends on for its oxygen supply is slowing down. The deep is being starved, not through one sudden event but through a slow withdrawal of the system that kept it alive. And then add the geology. Because the Mariana Trench doesn't sit on stable ground. It sits on one of the most seismically active boundaries on the planet, where the Pacific Plate is grinding beneath the Mariana Plate in a collision that generates constant geological stress. That stress releases through earthquakes, through hydrothermal vents pushing superheated chemically altered water into the surrounding environment, through the release of methane and hydrogen sulfide from deep sediment during periods of increased seismic activity. When that activity spikes, it doesn't just shake the seafloor. It changes the chemistry of the water immediately surrounding it. It introduces compounds that are hostile to life even in small concentrations. It raises local temperatures. It adds additional stress onto ecosystems that were already being pushed to their edge by the oxygen depletion happening above them. The Mariana Event wasn't one thing that happened on one day. It was several pressures, geological, chemical, thermal, converging simultaneously on a deep-sea ecosystem operating on zero margin. And what that ecosystem did in response was the only thing available to it. It moved. Now here's where the story gets complicated in a direction that I didn't fully anticipate when I started looking into this. The animals that made it out, the ones that survived the upward migration and established themselves in shallower waters, didn't just disappear into the background of their new environments. Some of them are thriving in ways that are destabilizing the ecosystems they entered. They're novel predators in waters that have no learned response to them. Nothing in shallow Pacific coastal ecosystems evolved alongside anglerfish or deep-sea eelpouts or certain species of viperfish. These animals are eating prey that previously had no predators capable of hunting them the way deep-sea hunters hunt. They're outcompeting surface fish for resources in ways that are shifting population balances in measurable directions. The migration was an ecological accident for the shallow ocean just as much as it was an escape route for the deep-sea animals attempting it. Accidental, unplanned, but the consequences are playing out in real time in fisheries and coastal ecosystems across the Pacific. And the deep they left behind? Still there. Still dark. Still under pressure. But significantly, measurably emptier. Research vessels that have sent acoustic equipment into the deep Pacific in the years following peak migration activity have reported striking reductions in biological signal from regions that previously showed dense life. The Mariana's deepest zones, which once returned rich in layered acoustic signatures when sonar was passed through them, now return quieter readings. Not silent, but quieter in ways that researchers describe with language that consistently has an uneasy edge to it. There's also what this means for carbon. The deep ocean isn't just where unusual fish live. It's one of the planet's most significant carbon storage systems. The seafloor accumulates organic matter, dead plankton, the bodies of larger animals, biological material from the surface that carried carbon downward over millions of years and locked it into sediment. The deep-sea organisms living in that environment process and stabilize that carbon, essentially keeping it out of circulation. disrupt that ecosystem, evict its inhabitants, reduce its biological activity, and the carbon doesn't stay stored. It re-enters the system. The ocean has been absorbing roughly a quarter of all human-produced carbon emissions for decades, acting as a buffer that doesn't get enough credit for how much it's been doing on behalf of the atmosphere. When the deep ocean's capacity to play that role weakens, the feedback is global, not local. And it doesn't come with a reset button. So is the ocean dying? I've been sitting with that question the whole time we've been going through this, and I keep landing in the same place. The ocean isn't dying in the way that word usually pictures. It isn't going still, it isn't going gray, it isn't shutting off. What it's doing is rearranging itself. Life that existed in one place is attempting to exist in other places, with varying success. Ecosystems that took millions of years to form are being unmade across timescales of decades rather than geological ages. The ocean is not dying. But it's becoming something meaningfully different from what it was, faster than it has at any point in recorded history, and the Mariana Event is one of the clearest demonstrations we've had yet that this transformation is not theoretical. It's not a projection. It's not a model. The fish already moved. The signals were already there. The deep is already quieter. The question that actually deserves your attention isn't whether the ocean is dying. It's what it means that all of this is already in motion, and most of the conversation about it hasn't reached the people it most directly affects. You're above the waterline. Everything you eat, breathe, and depend on to exist connects back in some chain to what's happening beneath it. The ocean regulates temperature. It produces oxygen. It absorbs carbon. It feeds billions of people. And right now, in the deepest and oldest part of it, the animals that lived there for millions of years decided that staying was no longer survivable. That decision alone should tell you everything about the direction this is heading. The question is whether we're paying attention before the next event, or after it.